Okay. Thank you, Tristan. I'm going to cover a lot of things as quickly as I can. I'm going to skip that part of the talk. No, I'm kidding. How many of you are already directly involved with OpenStack in some way? Jesus. Okay. How many of you find that to be a totally simple and seamless process getting involved? All right. What I will try and do today, cheating. Starting early is cheating. That was Monty Taylor in the back, of course. What I will try and do today is give you a little flavor of who I am and why I'm talking about OpenStack, and then a little bit of the history of OpenStack, which I always think is fun. It gives you some sense of, if we have to decide what OpenStack is, and we seem to have to do that again every 6 months, where we started from helps figure that out. And then a little bit of some taste of what the community is like, so that as you get more involved in OpenStack, the inside jokes start to make a little bit more sense. And then finally close, and I'm going to cram this in at the end, some idea of why OpenStack matters. So yes, it's enormously popular, and we can sort of talk about how enormously popular, but it's having a pretty profound effect, not just bringing about world peace and crushing the evil monopolies of Western capitalism or something, but hosting billions of pictures of cats, and this is important. As Tristan mentioned, or sort of briefly mentioned, I led an engineering team at NASA Ames Research Center, and we originally set out to solve hosting a lot of pictures of cats. Actually, not cats, Martians. Well, potential Martians, photos of the surface of Mars. And we were trying to do a lot of processing on those photos. And we were really trying to work on this thing that was this new idea at the time called open science. It was this intersection of open data and open government, where we wanted to be able to take the scientists inside NASA and have them collaborate with scientists outside of NASA without going through this 2-year process every time to get them a badge, an ID badge that would allow them to come on site. And it was a very weird experience that I won't really talk about too much, but suffice it to say, what we learned from that experience is that engineers are really bad at solving problems. We have never built the right solution to a problem ever. What we do is we oscillate towards progressively better solutions through a series of hopefully smaller and smaller mistakes. And so you can think of OpenStack as, along with tequila, the place where mistakes happen. It's worth noting that both OpenStack and tequila have some strong roots in Texas. I'm not saying that tequila was necessarily involved in the birth of OpenStack, but there's certainly some obvious correlations that can be drawn. Okay, story time. We were doing this thing at NASA, and there were some folks at Rackspace, John Dickinson and Monty Taylor and some others who were in the room or not, who were essentially doing exactly the same thing at Rackspace, and we weren't talking to each other, and we didn't know about it. And in the spring of 2011, I got really tired of working on this open source project at NASA where we had never released any source code, and I published a bunch of source code on my blog without any permission and promptly got in a lot of trouble. But in the process of that, these folks at Rackspace came across this source code and they said, wow, this is kind of sort of what we were going to work on, and they called us up and we had a very interesting dinner where we had to divide the check into 27 individual pieces because NASA can't buy anyone dinner ever. And somehow out of that we ended up with OpenStack. If you get me really drunk later, I will tell you the true story. That's the better story. The reason NASA was doing this originally was this thing called the Space Act, which essentially said NASA's job, aside from being astronauts and going into space, is to provide for the efficient use of science and technology on behalf of all of the agencies and all of mankind. It is the only US government agency that has a mandate for all of mankind instead of just for Americans. And the power of the Space Act is it lets NASA have arbitrary partnerships with anyone they want. NASA has partnerships with North Korea that the rest of the US government has no authority over. It makes a lot of people very uncomfortable. But it meant that we could have a partnership with Rackspace, and it really was nobody's business. Without the Space Act, OpenStack wouldn't exist. First, we wouldn't have built any of this stuff, but second, we wouldn't have been able to go out and collaborate with a broader community. But we still didn't know what we were doing when we did this, and so most of the story of OpenStack since then has been trying to figure out how to build a community, an open source community, and a culture around that community that doesn't look like this strange combination of government bureaucracy and Texans with tequila. This was the original roadmap for OpenStack. We thought this was going to take 5 years. Most of this got done in the first 2 years. Some of this we decided was a bad idea. I bring this slide up occasionally because we use almost exactly this process. If people start talking about like blueprints and you submit a patch and somebody reviews your patch and then there's these design summits and stuff, blueprints are basically like these cards. So that's your mental model. That's your first takeaway for today. When people talk about blueprints, they're talking about one idea for one feature that could fit on an index card. All of OpenStack is driven by blueprints. The last thing, before we get into what OpenStack actually is, this philosophy behind it, and I hate going after Radia. That was probably the best keynote I've ever seen in my entire life, so I have the worst slot in the day. You know, we're not drunken sports fans. We really do not believe in standards bodies, and OpenStack, despite a lot of public debate, was never about standards. No interest in standards at all. I think it's interesting. Interop is interesting, but the point of OpenStack originally was the ARPANET style standards process. Working code and loose consensus, and if somebody wants to write a draft about what that means later, awesome. But if we can prove that this scales to, I don't know, hundreds or thousands of individual clouds connected together and stuff actually works, you just call it a standard. So the committees inside OpenStack have some very bizarre dynamics because they're mostly composed of people who hate committees, which makes our meetings mostly drinking events. Okay, we have this OpenStack thing. Just to recap what it is the world's leading open source cloud framework, leading being there's thousands of people working on it. From some stats from the last summit, I'll just pull up, these are a little bit out of date. Companies keep joining. The fun part about this number is that everyone that we thought OpenStack was competing with is now a member of the OpenStack Foundation. So VMware joined, EMC joined, I mean the Red Hats and SUSEs and IBMs, that all sort of made sense. Citrix was a member for quite a while. Different story there. All right, there's a lot of interest. Obviously, people start realizing, as in any open source community, if there's a lot of people paying money for folks to work on this, then I could get paid a lot of money to work on it. So this is job searches, basically. It's been going pretty steadily up. The number of developers committing on a monthly basis continues to go up. And this last slide embarrasses me a little bit. Our code base has become enormous. I think my goal for 2013 is to make that line start going back down. I think we have so many people writing so much code so fast right now that it's impossible for anyone in the project to have a good sense of what's going on across the whole project. And we have, you know, Red Hat especially has been leading an effort to try and isolate common code across all of the various OpenStack components. You know, remember, drunk Texans and astronauts trying to collaborate. We sometimes have architecture debates about the right way to do things. Okay, OpenStack came out of this thing with NASA and Rackspace, and if you think about those two organizations, we don't have the same goals. The biggest problem we were trying to deal with at NASA is that nobody else in the rest of the world was allowed to touch our infrastructure. So we wanted our infrastructure on the inside to look exactly like what people could use on the outside, so that they never had to be let into our system. I mean, the process at the time for someone to get a VPN account so that some Australian could be a collaborator, minimum of 6 months. In a lot of cases, their grant money would run out before they got a VPN account. I had an intern on our team for 18 weeks. It took us 12 weeks to get him a laptop. I'm serious. This is not effective. So we were building private clouds. Rackspace, on the other hand, has one of the largest public cloud environments in the world, and their concerns were all about how do I have the largest number of users who are all roughly happy. Scale in an odd sense, very large scale on both sides. I think for our first customer, we had as much data as a couple thousand Rackspace customers. But nonetheless, large scale on both sides, but different kinds of scale. So OpenStack had this philosophy that said we've got to be able to build private and public clouds using the same technology and the same approach. And the nice side effect of that is it ends up looking a bit like the standards efforts, and careful with that word standards, that pushed forward the internet. In that we ended up, whether it was on purpose or not, we ended up with a single set of protocols and technologies that could be used for private networks and public networks, and the side effect of that was enormous. We wouldn't have had anything like the World Wide Web without that. So there are these two kinds of clouds. There are three kinds of interfaces, and this was a big philosophical driver. This is, broadly speaking, what's known as Web 2.0 philosophy, is the interface that the human deals with, the dashboard, and the command line tools under the hood should consume the same API. And that API, that web-based API, is the only real interface to OpenStack. So never cheat. Never build a dashboard that doesn't consume the API. What this means is anything you can do as a human with OpenStack, you can write software to do with OpenStack as well. Right? So the ecosystem of other people building tools on top of OpenStack that makes OpenStack do odd things. I know there's folks in the room working on making OpenStack install OpenStack. Personally think it is a little weird, but the fact that it's possible is pretty awesome. So there's three interfaces, two kinds of cloud, and the increasingly incorrect original diagram of OpenStack is here. Your applications, your dashboard. There are now about 9 components under here. Nobody in the foundation has any interest in updating this diagram because we're not sure if the projects are going to stay in or go out. So let's just think roughly that it's compute, networking, and storage. So we think of these 4 resources: compute, networking, storage, and then your interface layers on top of that. I'm going to get towards the end, if I have time, talking about the impact of this change of philosophy. But if we think back to the effect of the internet, well, let me take a different angle. If we think about the Apple I, how many of you ever used an Apple I? Wow. Okay, like 4 people. The Apple I, and some of you are going to argue with me about this, but roughly speaking, was the day when you didn't have to be a hardware engineer to be a software engineer. Not only did you not have to work with the hardware, you didn't have to understand what was going on. It was a successful abstraction that meant that you didn't have to have a whole set of skills anymore. And the goal with the software-defined data center, or true cloud, or API-driven infrastructure, or whatever term you like, is that you can be a software developer and never think about the infrastructure again. Never physically touch a server, hopefully never think about installing an operating system and updating it, because frankly, it's really boring after the first 400 or 500 times. How many of you are Gen 2 users? Okay, you might disagree with me on the boring side. Okay, let's talk about these. So the goal with the APIs is that the API you use for dealing with your storage, and the API you use for dealing with your compute resources, and the API you use for dealing with your networking should, roughly speaking, feel like the same thing. Because it should be the same user of all of those APIs. Your developer is king. In the world of cloud, the developer is who matters. They're the person. It's API, it's software-defined networking, meaning that the application developer who's writing that software is in charge of what the network needs to do. Not how it's provisioned, but what it delivers. All right, let's talk. I'm going to cover both some aspects of the community and some aspects of these pools. Now, OpenStack as an organization is loosely divided into these projects that are semi-autonomous. And so we talk about folks like John Dickinson, who's in the room, who is the project technical lead for Swift. Swift can do whatever they want as a project, and they mostly do. They are held loosely into this umbrella of OpenStack by a common release schedule, common tooling, common philosophy, but these projects are semi-autonomous. So the compute project, which is called Nova, you hear people talking about Nova all the time, they're talking about compute, which doesn't necessarily mean virtual servers, but it mostly does. And for a long time, although probably not forever, this guy named Vish has been the project technical lead for Nova. So when you get involved with OpenStack, and I assume you will get involved with OpenStack because we won't let you out of the room until you sign the contributor's license agreement, at some point you will end up interacting with Vish, and that will be a good day. The idea behind the abstraction of compute is that this is scheduling and launching stuff. Now, there's folks who are going to talk later today about using Nova to schedule and launch bare metal. It doesn't have to be a virtual machine. It can be a logical container. It can be OpenVZ. It can be GPUs. Notionally, it could be all sorts of bizarre things as well, but those are roughly what's covered today. Scheduling means deciding where a workload should go, and that's it. So which server is going to take this workload? All right, that's compute. Object storage, that guy's face you might recognize, that would be John Dickinson. Some of you may still be wearing the John Dickinson fan club stickers from last night. That's what got you that free beer. Scale-out storage, you're going to talk all about this. Swift, giant photos of cats, billions of photos of cats, no POSIX. Awesome, okay. Very high level, durable, available, lots and lots of simultaneous users, lots of data, no memory mapping. If you're in the HPC community, close to what you want, but not necessarily. We use this a lot at NASA. This is where all those photos of Martians went. There is another kind of storage, obviously, which is block stores that feel like hard drives. Think of them as USB hard drives without the USB cables. Headed up by this fellow John Griffith at SolidFire, a relatively new OpenStack project, which is somewhat confusing because it's always been an OpenStack. It just used to be part of Nova. It's got POSIX semantics. And it can be, in fact, in most environments, is high performance, but it's not infinitely scalable the way that Swift is. Swift, you can store as much data as you want. You know, a Cinder block device is going to be whatever, some dozens of gigs. That's what you get. Networking, quantum. Quantum is the super sexy thing inside OpenStack because SDN is super sexy. I'm going to talk, actually, let me pause for just a moment here. One of the things that OpenStack has going for it as far as a community is it has a very healthy and confusing relationship between commercial capitalists and folks who care mostly about the open source ethos of the project and are kind of oblivious to the fact that somebody somewhere is probably making money. There are like $5 trillion worth of market cap in the companies involved in OpenStack. The foundation by itself is spending, what, $10 million a year right now, I think? So this is big business. I know of one person out of the 700 people who committed code in the last release who is not paid to do so. So this is not volunteerism. This is not open source because people care. I mean, not that people don't care. I mean, there's a lot of folks in this community who've changed employers 3 or 4 times, like they change underwear once every 3 months. But people are getting paid to work on OpenStack. And the nice thing about that is we knew that was going to be true from day one. It's hard to work on OpenStack without an employer paying for it because it takes a lot of hardware to have a cloud. Setting up a cloud on your laptop is not terribly effective. For my company, we figure it's a minimum of $10,000 to $20,000 worth of hardware per developer. Most hobbyists do not have $20,000 worth of servers in their closet to play with. Some of you do. Probably more of you than your standard deviation in the population. So back to Quantum. When Quantum was launched, we did have a networking project already called Nova Networks. It was not very good. I wrote it so I can mock it. It was really bad. And the initial founding partners of the Quantum project were Cisco, Arista, Nicira, Metacora, and Juniper, thank you, and Big Switch as well. Every single one of them was a major commercial vendor with an agenda to make money off of SDN. And so the Quantum project was built very deliberately. Yeah, it's open source. Yes, there's a free open source implementation of Quantum as a plugin that you can use. Most people buy one of the commercial ones. That doesn't mean anyone in the community would object if you made the free one better. But it gives this really interesting flavor. And so in a lot of cases, the first place I see people stumble when they get involved in OpenStack is expecting it to be free all the way down, and they run into things like Quantum. They're like, wait, there's these paid plugins, and there's like, what's going on? So that's what's going on. It works really well because we have a lot of people working on Quantum, and the free version is quite good. It also works really well because the adoption of SDN for the whole industry has been moving faster, because now folks who were nervous about it, they're like, well, we don't know which vendor to pick, so we're going to wait. Now they're like, well, we'll just use the Quantum API, and then if we pick the wrong vendor, we can change the vendor out without worrying about it later. That's the same approach, by the way, that went into Cinder. Cinder kickoff was, NetApp and EMC, SolidFire, Rising Tide, Inktank. All of them are commercial storage vendors with a goal to say, hey, let's have open source, let's have a free version, let's sell our commercial plugins, see how that plays out. All right. Shared services. There's a whole bunch of other components I'm glossing over. There are some new entrants to OpenStack Core that I have skipped. There's a rule that basically says people can't learn more than 3 new things at a time. So there are 3 main components in OpenStack: the storage, compute, and networking, plus a bunch of other stuff. If you're going to launch images, you need somewhere to keep them. That's the registry. That's Glance. If you have users have to authenticate against the system somewhere. The middleware that lets you deal with that is Keystone. And I mentioned Red Hat really pushing this effort to have common code in common places so that OpenStack as a whole has a little bit more coherence. That is now this thing called Oslo. There are lots of others. I have skipped some that folks will be grouchy about. The whole continuous integration framework run by Monty Taylor, who's in the back. I'm not slighting it, just most developers don't have to deal with it on the first day. It's like the 4th day. When their patch lands, then all of a sudden they're worried. All right, the last piece, and remember, you're going to sign the CLA before you leave the room, so you may want to pay attention to this part. Governance. There was a huge debate when we set up the OpenStack Foundation. It was like, why don't you just give OpenStack to Apache? Why don't you just make it an Eclipse project? Why don't you use one of these other existing foundations? The main reason was because we had this balance between commercial interests and traditional free software. If you look at most open source efforts, they are dominated, if there is a commercial vendor at all, by 1 or 2 major vendors. It is hard to use an existing open source foundation and not end up with that dynamic. We had a lot of folks pushing us to sign up for the Eclipse Foundation. None of the founders of OpenStack would have been able to achieve anything close to influence inside Eclipse. We'd never be able to be platinum members in Eclipse. So, it was essentially them saying, hey, why don't you give us your project and let us run it forward the way we would like? So we created this new foundation. We spent a ridiculous amount of time on the bylaws and the drafting committee process, and we ended up with something that everyone hates. But roughly speaking, we all hate it equally, which I think was the best we were going to hope for. There is an endless amount of complaint about the election process and who's on which governing board. Despite all of that, it tends to work pretty well. So the board sounds super important. We do very dull things. Mostly what we do is argue about marketing. Our product's going to be called powered by OpenStack or built on OpenStack? Or can you use the word OpenStack in your actual product name? I kid you not. I have spent like hundreds of hours of my life on that discussion. So, the point of the board really is to keep suits like myself out of the way of the people doing the real work, which would be the technical committee. We've also made the technical committee totally confusing to corporate people. We use Condorcet voting, which means they don't even understand how to run. It is, roughly speaking, a meritocracy. It works really, really well, surprisingly. We've all been very nervous since the early days. The TC has changed its name 4 times. And the internal governance gets like rewritten every couple of days by the people involved. Despite which, it continues to work really well. And what they do, roughly speaking, is they keep these autonomous projects from going off in totally different directions. So they talk about, Oslo and OpenStack Common and the release schedule, and are we going to switch from Tornado to Twisted, and what about tearing out RabbitMQ, and real technical discussions that impact the quality of the software itself. And then finally, we have a users committee. How am I doing for time? Like 5? Okay. The users committee, this idea, I've been doing open source for a long time, and I'm not a very good open source person in the sense that I tend to disagree with everybody else. I worked on the Mozilla code base on and with it for a long time at Netscape and Flock, which means from most Mozilla people's standpoint, I'm evil. And I was really concerned that the development was driven by the developers. It's a scratch your own itch problem, where the users had a very hard time influencing that community except by submitting patches, which is not very easy. Writing code and getting it landed in OpenStack is hard. It is a complex distributed system. We have kept it as easy as possible. It's almost all in one language. We try and document it. We really focus on user groups, but it's still hard to get a patch landed. And so for folks who are actually trying to use OpenStack, we wanted there to be an alternate mechanism to contribute, feedback on what was important in the product without just, trying to submit patches. So that's the user committee. It's still in sort of formation, but Tim Bell of CERN and Ryan Lane from Wikimedia, I think Tom's a little bit involved as well from the Nectar guys. Really the idea is just the folks using OpenStack should have a voice in how it works and what it does. All right. I will speed up a little bit. This is kind of those roles of those various organizations again. Full membership votes on the board. Active technical contributors vote for the technical committee. The way the user group is built is still in flux. This is an increasingly out-of-date diagram. I was trying to give folks a flavor of how big is this community and how diverse is it. This slide is old, but roughly speaking, there were originally, 19 companies that were foundation members. It means we committed to paying a lot of money every year to keep the foundation going. Most of those were organizations that were involved very early on in the development of the software as well. Now we have corporate sponsors, and we have folks just submitting patches, and we have just the ridiculously broad community. This is a lousy way of looking at it. So if we look at humans instead, this was Texas of 2010. It's one of the first big summits. There was, I don't know, 500 or 600 people. Huh? Second big summit. It was the second big summit. Third, actually, if you count the Austin one. And the second? Okay, you're right. So the first one didn't happen, though. One of the first. So who was in that picture? Yes. Anybody else? Yeah, who else was in that room? Okay, just a couple. Good to know. This was Santa Clara, 6 months later, about twice as many people. And that's actually the last photo we have that shows most of the summit in one room, because we never figured out how to photograph it afterwards. I mean, it was blew past 1,200 to like 1,500 people the last summit. None of the summits have had a room that really had everyone in them anymore. But there's also, several hundred people, user group in Japan, the Korean user group. I mean, Tristan mentioned the one in China. We now have a map of the user groups around the world. And it's ridiculous. Like, there is something about OpenStack right now that excited people all over the world. And I'll take just a second to speculate on what that is. And then I'll take a couple of questions. I might have 1 minute for questions. The thing that happened with the Apple I meant that there was an entire generation of people who had never been hardware engineers who grew up as software engineers. How many of you have like an ME or a double E background? Okay, keep your hands up, keep your hands up. Now of those, how many of you are over 40? Okay, most of you. I never worked with hardware. I started as a software person, and I didn't realize until I got older that all of my older peers had been hardware folks first. And I think we're starting to get in this generation now where you can be a software engineer and build a massive global distributed system and not have to think about the underlying infrastructure. And that's exciting because every time we go through this transition, it's terrifying for the old guard. I should describe this as pin setters. We didn't stop bowling, but people stopped standing up the pins. So it looks like your job's going away, right? If you're a sysadmin today and all of a sudden we don't need sysadmins, oh my God, does that mean I'm out of work? But every time we've gone through that transition, we've ended up with 10 times as many jobs on the other side in doing something that's actually more interesting, more creative, and usually more lucrative. You get paid more to do cooler work in a field that looks mostly like the field you just left. I think that's from the user community side, that's why everyone's so excited with OpenStack. From the ecosystem side, OpenStack has become like it's cool to work on infrastructure again. It's been not cool for a while. Trying to hire people to come work at the team at NASA, even though it's like, hey, come work for NASA? It was impossible because what we were doing was really fundamentally dull. And for some reason, OpenStack was successful at making really dull things very sexy. So I would like to invite all of you to get involved in doing really dull things that will make you seem more attractive to the opposite sex. All right, I'll take a couple of questions if we have 1 minute left for questions. I can repeat them or you can run the mic.
Hi, I came in sort of knowing almost nothing about what the project is and what it does. Can you give us an example of how people actually use it without using the word cloud?
Sure. Yes. I can promise to never use the word cloud again. API-driven infrastructure means essentially provisioning of, let's say, virtual machines, virtual networks, and virtual block devices using API calls. So most folks that use OpenStack do not directly use OpenStack. They use some set of tools on top. Let's take Puppet and Chef as an example. A lot of folks use Puppet and Chef or Cloud Envy or RightScale or Scalar or Stratus or Service Mesh or any one of these sort of orchestration tools to select from a service catalog and say, hey, look, I need an elastically scaling tier of web servers. I need a bunch of Nginx boxes and a bunch of boxes running my Junicorn app, whatever it is, and a bunch of load balancers above that. And I'll give you a personal example. While I was at NASA, I was also running web for this thing called The Buried Life. It's an MTV reality show. It's a bunch of friends of mine. And during that period of time, they appeared on Oprah. So we were hosting their web app on API-driven infrastructure at the time, and it was using 4 or 5 virtual machines. And in the first 4 minutes of the Oprah show, it scaled up to about 65 virtual machines. And we didn't have to touch anything. And then after the show was over, it went back down to just a couple, and it didn't crash. So that was the magic of this elastic API-driven infrastructure was rather than having a sysadmin log in and spin up more VMs and reconfigure the load balancer to use those additional servers, the API-driven nature of that infrastructure meant that we had software monitoring load and directly responding by increasing capacity. That's a super typical case. NASA, we did something similar for reprocessing photos of the surface of the moon to build 3D terrain maps. And again, when we had new data coming in from the Lunar Reconnaissance Orbiter, it would automatically spin up more VMs. It would process the new images, move them somewhere where they could be directly served out to Google Mars, Google Moon, Microsoft Worldwide Telescope, and then the VMs would get spun down again. So we were able to share a lot of infrastructure with other science projects without having humans involved in making those decisions of whose VMs are going to get turned off and whose VMs are going to get turned on. Nectar provides an OpenStack-based cloud for a lot of scientific researches. I know Tom's going to talk about that one. Yeah.
Use my cloud.
Ah! Twice. It's not bad, though, right? It's close. One other one? Yeah.
Why do you have a contributor agreement?
It's an Apache 2 licensed project, so arguably we don't need one. The short answer is it's a very commercial-rich ecosystem, and the commercial partners are much more comfortable if we have some copyright assignment in place. No, sorry, it's not in CLA. It is a what the hell? I haven't even looked at the language in like a year and a half since we put it in place.
Just asserts that you're contributing the code under the terms of the Apache license. So you're signing that you are in fact
The contributor. Yeah.
That's not a copyright assignment.
No, there's no copyright. Sorry, it is an assertion that the code that you are submitting is code that you have the right to submit.
Right.
Yeah.
It also says that you have a license, irrevocable license to use it however you like, but there's no statement that OpenStack will always remain free and under the Apache 2 license as far as I can see. So if you're granting a license to OpenStack, they could make a commercial down the track.
No, that's not true. Bring in the lawyers.
Please know, I spent 6 months of my life on the drafting committee with the lawyers. I don't ever want to go back.
It's not an assignment. So
Yeah.
the OpenStack Foundation cannot change the copyright of the code that you contributed under it after the fact. It will remain copyright you. You just contributed under the terms of the Apache license.
There were a bunch of
It's not assigning copyright to it. They cannot change
Right.
the terms of the license.
There was a bunch of copyright assignment done in the early part of OpenStack, a la my team contributing copyright to NASA and various Rackspace employees. It's not required. It is not part of the CLA anymore. I don't think it,
In fact, we actually need to send a message to mailing list telling people to stop getting copyright OpenStack LLC at the top of their files.
yes.
That entity doesn't even exist anymore.
Yeah.
So,
Yeah.
anyway.
Yeah. So the reason there's a CLA, just to summarize, is because lawyers are nervous that you will submit code that you do not own, and that OpenStack would therefore be liable for you having done something that's notionally illegal. Yeah. All right. Thanks. I'm
Thanks, Josh.